Hi folks, we're going to take a look at this question here. So they give us some information about an angle 2x, and they tell us that it lies in the third quadrant, and they give us its exact cosine value. So let's take a look at what they're asking us to do. So first of all, sketch the location of 2x. Okay, not much to do there. They just tell us that it's in the third quadrant. So I'll just draw some random angle in the third quadrant, and this will be my angle 2x. Okay, not much else to do there. So in part B, they ask us to determine the quadrant for angle x. Okay, well, this is a bit more interesting here because clearly it's related to 2x. X is half of 2x, so we need to figure out in what quadrant it'll be. So this is the approach I'm going to take. In order for 2x to be in the third quadrant, it means it has to be bigger than pi and less than 3 pi over 2. That's the smallest possible angle it could be. That's the largest possible angle it could be. So I'm going to take this smallest possible angle and just divide it by 2. So I know that x can't be smaller than pi over 2. Okay, and similarly, I'm going to take the largest possible angle for 2x, which is 3 pi over 2, and I'll divide that in half. So that means x can't be any larger than, well, what's 3 pi over 2 divided by 2? That's just going to be 3 pi over 4. So that means that x has to lie somewhere in this area here between pi over 2 and 3 pi over 4. So in fact, we can even be more precise than saying what quadrant's it in. We can actually say we know it's in the second quadrant. We can say it's between pi over 2 and 3 pi over 4. Okay, so here x must be in the second quadrant. In fact, between pi over 2 and 3 pi over 4. Okay, might not be necessary for what we need to do, but an interesting fact that we can be more precise than giving a whole quadrant. All right, so presumably we'll need this information to solve part C. It seems like an odd question to ask unless it was necessary. So here they're asking us to find an exact value for cosine of x. Okay, but the information they give us relates to cosine of 2x. So we have to ask ourselves, is there a connection between cos 2x and cos of x on its own? Okay, and this is where I hope you'll think about looking at your formula sheet at those double angle formulas. And we see that for cos of 2a, we've got 3 possible options. And one of those options is equal to an expression that has only cosine in it. The other two, this one's got cosine sine, this has just the sine value in it. This is the one that relates cosine of an angle to cosine of 2 times that angle. So that's the one I'm going to work with here. All right, so here I know that cos 2x is equal to negative 6 over 15, which in fact we can simplify. Divide numerator and denominator by 3, so that's negative 2 over 5. All right, I know that cos 2x can be written as 2 cos squared x minus 1. So that's also equal to negative 2 over 5. And now look what I can do. I can just solve for cos x. Okay, so 2 cos squared x is equal to negative 2 over 5 plus 1. So plus 5 over 5. So cos squared x is equal to, well, negative 2 plus 5, so 3 over 5 divided by 2, when I bring the 2 to the other side, or multiplied by a half. Okay, and so now I can just take the square root of both sides. So this just ends up being 3 over 10. And I'm taking the square root, so I'm taking the positive and negative square root. And there I have possible answers for cos x. Okay, but cos of x, whatever that angle is, okay, can't have 2 values. It can only have 1 value. So now we see why it was important to answer part B. Okay, we needed to figure out what quadrant x was going to be in. So here we could choose which of the 2 answers is the valid one in this case here. So since x is in the second quadrant, we know that its cosine value has to be negative. Okay, so we can say cos x is equal to negative root 3 over 10. Okay, since x is in the second quadrant. Okay, if I was looking for the sine value, well then I would have chosen the positive version since sine is positive in the second quadrant. Okay, so just to recap, okay, part one, nice and easy, just draw anything in the third quadrant. Part two, what we did is we used the fact that being in the third quadrant meant you had to be at least pi radians and at most 3 pi over 2 radians, and so we were able to divide those by 2 to figure out the minimum and maximum possible values for x, and then from there we use the relationship between cos 2x and cos x using our one of our double angle formulas for cos x, and then we solved for the thing we're looking for, which was cos x, and we used our answer in B to determine that we needed to take the negative value instead of the positive one. Okay, that's it for this one.